This is a brief introduction to the Advanced Grid Maker, a superb software application written by John Allwine. John has generously made this application free, yes, I did say free, for anyone to use. This video barely scratches the surface of the Advanced Grid Maker, but it will enable you to use the application to tie single-strand Turk's heads. The first 3 minutes or so do include a bit of theory, which is not absolutely necessary before using the Grid Maker, but please take the time to watch it before getting stuck in. If you do a Google search for Advanced Grid Maker, the application will be listed, as you can see here. When you open the page, make sure you bookmark it so you always have it available in your browser. Note that Internet Explorer is not supported. The recommended browsers are Firefox and Chrome. This video will concentrate on the absolute basics, tying simple Turk's heads with a single strand. I'll produce more advanced videos in due course. First of all, just a little bit of theory on Turk's heads. Here's an extract from a document I wrote to introduce Turk's heads. The relevant bit being an explanation of what parts, sometimes called leads, and bytes are. Even understanding this is not entirely necessary to start using the Grid Maker, but I thought I'd show you anyway. Here's a little more theory, but don't worry too much if you don't understand this just yet. In order to tie a Turk's head with a single strand, in other words just one piece of cord, the number of parts, or leads, and bytes must be co-prime. Now don't panic. I'll explain what that means. It's quite simple. Co-prime means that the number of parts and the number of bytes must not be divisible by a common number, apart from the number 1. Some examples. Can we tie a simple Turk's head with 7 parts and 5 bytes? Yes, we can, because neither of these numbers are divisible by any other number than 1. Can we tie a 10-part, 6-byte Turk's head? No, we can't, because both of these are divisible by 2. Can we tie a 12-part, 13-byte Turk's head? Yes, we can, because neither of these numbers are divisible by any other number than 1. Starting to get the idea? There are numerous books on Turk's heads, and many of these include a table indicating what combinations of parts and bytes are valid, but now you know how to work it out for yourself. More often than not, a Turk's head is tied around a cylinder. You can use any cylindrical object, from a toilet roll holder to a foam-based pipe insulation. Pins are usually placed at either end to wrap the cord round as you go from one side of the knot to the other. In the Advanced Grid Maker, the pins at either end of the knot are indicated by A and B, and each pin also has a number. This will become obvious when we take our first look at the Advanced Grid Maker. Okay, let's get started and have a look. Don't be intimidated by the number of boxes on the page. You'll need very few of them to get started tying simple Turk's heads. At the top of the page there are a couple of links to freaking sweet knots and freaking sweet apps. You really should check these out. There's some phenomenal stuff there. A bit lower down there are linked to 3 documents that have helped me certainly get started with the Advanced Grid Maker, and I thoroughly recommend checking these out. I think that some of these are perhaps work in progress, so keep an eye on them. They may change as time goes on. What do we need to look at then to tie a simple single strand Turk's head? Let's look at these boxes. We can forget about stretch and resize for the time being. Row coding and column coding, we'll just look at column coding for this one. Tile coding, not interested. The next two, locked gaucho and dog bone, no. Colours, we're only going to use one strand, and the default here is the colour Peru. You can use most common colours: white, black, blue, brown, yellow, red, and so on. And when we look at the diagram produced by the grid maker, we can define what colour we want the shadow colour to be. Let's leave these at the default for now. Strand width and strand gap size. I'm not going to worry too much about this, but suffice to say that the strand width will give you an indication of how much cord you will need to tie a particular knot. We'll leave this at the default of 0.125 inches, and the strand gap size again 0.125 inches. Dots per inch, that's the DPI, that's the resolution that it's going to be shown on screen. The next thing we're interested in is the number of parts and the number of bytes. I'll come back to this because this is the important part for tying simple Turk's heads. Display options, no, we don't need to know anything about those. Generally leave the autofill grid option on, and the only box we're interested in below that is the standard grid. Interactive options, no, don't need to know anything about those. And let's move down. This is a diagram produced by Advanced Grid Maker. If we go back up, we'll see that we've got 13 parts and 9 bytes. So this is the diagram that it would produce for us. And if we look just above the diagram, we've got half cycle, and in fact it's showing the last half cycle that we need to tie to finish this knot. What is a half cycle? Well, a half cycle is when you move from one side of the knot to the other, in other words from A to B. If I just click this arrow on, it will show you the first half cycle. So you go from side A, pin 1, to side B, pin 7. And the run list there just has a row of dots. That means we don't have to go over or under anything. Well, that makes sense, doesn't it? There isn't much to go over or under yet. Let's move to half cycle 2. That tells us to go back from B7 to A5, and we've got to go over one strand. The next one, we've got to go from A5, where we finished last time from the last half cycle, down to B2, and we've got to go over one again. From B2 to A9, we're actually going to go over 2. And the wonderful thing about this is you can read the half cycle from these instructions here, and you can also follow the diagram. And if we keep moving on, it will show us, I know there are 18 half cycles. Why there are 18? Because there are 9 bytes. So you're going from top to bottom to top to bottom, etc., etc. So the number of half cycles will be twice the number of bytes, basically. And that's a very good way of seeing how to tie the knot going through the half cycles. But if we scroll down a bit, the next thing we're interested in is, well, strand length. Do you remember we looked at the strand width being 0.125 inches? Well, this is telling us that if we want to tie this with one strand, we will need 5 feet 5.405 inches. Now just take this as a guide, because often when you tie a Turk's head you'll want to tighten it up later, so you generally use a little bit more than is required to start with. It's one of those things that you really need to suck and see to get a feel for how much you need. And down, instructions. Now these are the same instructions as we saw above when we went through the half cycles, but this lists them in a table for us. And it says here strand 1 brackets Peru. Peru is the colour that we opted for. It was the default. If we were using more than one strand, there would be instructions below for strand 2 red, white, whatever, strand 3 and so on. But we're only tying single strand Turk's heads here, so there's only one strand. We go down and we don't need any of this. Do you remember the examples I looked at earlier when I was talking about what was a valid combination of parts and bytes? Well, the first one I looked at was 7 parts, 5 bytes, and we know that that's a valid single strand Turk's head because they are co-prime. In other words, neither number is divisible by any common number other than 1. So let's put that in. 7 parts, 5 bytes. I'll click on column coding and standard grid. Let's see what happens. That looks like it, and that will give us the instructions to tie a 7-part 5-byte Turk's head. The next example I quoted was a 10-part 6-byte Turk's head. Now this is not co-prime because these numbers are not only divisible by 1 but they're divisible by 2, so it shouldn't be possible to tie a 10-part 6-byte single-stranded Turk's head. I've entered those in, click on column coding and standard grid. Let's go down. There's a 6 bytes. If we go down, look at strand lengths. It needs 2 strands to tie that. Well, that's for a future lesson. We can't do that one, not with 1 strand anyway. What was the next one? That was 12 part 13 byte Turk's head. So I'll enter those in, click column coding and standard grid. There we go. Yes, that should be valid. Let's just check down here. Yes, 1 strand. There we go. When I look at the first half cycle, obviously it doesn't cross anything. In this case, neither does the second, or the third. The fourth does. And you see there, the first crossing we come across is an under. Well, personally, when I'm tying Turk's heads, I prefer to get as many overs out of the way before I start on the unders. It just makes it easier to get started, generally speaking anyway. So that's as it goes under. Let me go back to the top, and you see where it says column coding under over. Let me change that to over under. And look at this again, column coding, standard grid, and let's have a look at this again. 1, 2, 3, 4. Yes, this time it goes over. So if you want to basically toggle the overs and unders, ultimately, of course, when your knot is finished, you can follow the strands and it will go over, under, etc. But I find this useful sometimes to just make sure that the first one at least is over. Doesn't really matter, just one of those finer points. Let's try something a little different. I've entered here 35 parts rather, and 13 bytes. That's got to make this quite a long Turk's head. So I've entered the parts and bytes, click on column coding and standard grid. Let's scroll down. How many bytes did I say? Bytes 13. Yes, that is quite long. And if I scroll down, yes, 1 strand, look at the instructions there. From A1 to B5, you have to go around once before you get to B5. What does that mean? Well, let's have a look at the first half cycle. Yes, you can see we've had to actually go round our virtual cylinder once before we get to the bottom, to B5. A1 to B5, around 1 times, yes. Now I've got clicked here, consolidate overs and unders. If I untick that and look at the instructions, it doesn't actually tell me that I've got to go around once. And what about these instructions? One. It doesn't say anything about going round once, so it's probably best always to tick this consolidate overs and unders box. That way it will tell you whether you need to go round the cylinder once with longer knots, maybe even twice or more. Let's have a look. Half cycle 1, around 1 times from A1 to B5. So yes, that consolidate overs and unders is probably worth keeping on all the time, actually. And finally, let's just go back to strand width and strand gap size. It doesn't really matter what the width is, but if I change the gap size to 0, column coding, standard grid, and have a look at the diagram, whoa, see there, it's filled all the gaps. So it's not really that easy to follow. It is if you look at the half cycles, of course, but it fills all the gaps in between. So bear that in mind. If I change that to 0.005, let's see what happens. Click on column coding and standard grid. Yes, we can see a little bit of a gap there. One last point. Here are a couple of Turk's heads that I've tied, and it may appear to you as though there are 2 leads used in these Turk's heads. Well, that's not true. These are single-strand Turk's heads. It's just that I've doubled the leads on each. In other words, when I've finished the original knot, I've then followed the original lead round again. Of course, this does mean that you need twice as much cord, so if you're trying to work out how much cord you need, bear this in mind. If you want to double the leads or treble the leads, make sure you've got enough. There's nothing worse than tying a complicated Turk's head and finding that you're an inch short at the end. I do hope this video has helped somebody somewhere. Future videos will look at multi-strand Turk's heads, gaucho knots, herringbone knots and pineapple knots. See you there. Thanks for watching.